Ever get frustrated with like how quickly your phone battery drains?
Oh, yeah,
Or like when your laptop starts to sound like a jet engine when you're trying to play the latest games?
for sure.
It feels like we're constantly hitting these limits of what our devices can actually handle.
Yeah, and you're right. There are limits, and a big one is heat.
Heat.
Yeah, computer chips.
Mm.
The brains of all our devices
Right.
generate a lot of heat, and managing that heat is a major challenge in making them faster and more efficient.
Okay, so that's the problem. Our devices are getting hotter and it's holding them back. But, I came across some research from the University of Virginia that might have a solution. They're diving deep into this world of nanoscale heat flow, and the findings are
Nanoscale.
pretty wild.
Yeah, what's fascinating here is that they're working with copper,
Oh.
which we all know is like a fantastic conductor of electricity.
Mhm.
That's why it's used so much in electronics.
Right.
But at incredibly tiny scales.
Tiny.
We're talking thousands of times smaller than a human hair.
Copper starts to lose its mojo.
So even copper has its limits.
It does.
Why does that happen?
Well, even copper experiences resistance to the flow of electrons, especially when you're dealing with these nanoscale dimensions.
Okay.
It's kind of like trying to fit a whole orchestra through a revolving door.
Oh, wow.
Things get jammed up, and that creates friction-generating heat.
Oh, I see. I'm starting to get the picture here. So how did the researchers actually measure this heat at such a tiny scale?
Right.
The article mentions something called steady-state thermoreflectance.
Yeah.
Sounds a bit like science fiction to me.
It does have a bit of a ring to it, doesn't it?
Yeah.
But it's a very real and incredibly precise technique.
Okay.
Essentially, they use lasers to measure how the copper film reflects light.
Mm-hmm.
And by analyzing those reflections,
Okay.
they can determine the temperature with amazing accuracy.
Wow.
This is how they were able to confirm for the first time that a long-held physics principle called Mathiessen's rule actually works even at these tiny sizes.
Mathiessen's rule. Now, that sounds like a character from a Tolkien novel.
Uh-huh.
But seriously, why should we care about some obscure physics rule being proven right at the nanoscale?
You might be surprised, but this is a game changer.
Okay.
Mathiessen's rule basically predicts how much resistance increases as things get smaller.
Okay.
By confirming it at these incredibly tiny scales, it gives chip designers a tool to predict and control heat buildup in copper films with much greater accuracy.
So it's like having a roadmap to make cooler, more powerful chips?
Yeah.
But what does that mean for the everyday user? Will we actually see a difference in our devices?
Absolutely.
Really?
Imagine your phone lasting twice as long on a single charge, or your gaming PC running silently even under heavy load.
Wow.
That's the kind of impact this research could have.
Now that's something I can get behind. And it sounds like a win for the environment too, right?
Yeah,
Less heat means less energy wasted.
it's exactly. We're all concerned about sustainability, and this research could lead to significant improvements in energy efficiency across a wide range of devices.
Yeah.
It's worth noting that this study was a collaboration between UVA Intel and the Semiconductor Research Corporation.
So this isn't just some ivory tower research. It has real-world backing. And the fact that Intel is involved suggests they see the potential of this discovery.
Yeah,
And it's not just about copper. This study sets a standard for understanding material behavior at the nanoscale.
Right.
We're talking about the building blocks of everything from the CMOS technology that powers your smartphone to the massive servers running complex AI algorithms.
Exactly.
Wow, it's like this one study has opened up a whole new world of possibilities. We've cracked the code on heat at the nanoscale. What's next?
Well, if we can control heat this well in copper, imagine what we can do with other materials.
Right.
This could be just the beginning of a whole new era in material science and electronics.
This is getting me really excited. We're talking about a potential revolution in how we design and build the devices that power our lives. But before we get too carried away, let's take a step back and break down exactly how this research could change the game. What are the practical implications of this breakthrough? What specific changes could we see in the way chips are designed and manufactured? And what does this mean for the future of fields like artificial intelligence and high-performance computing, which are already pushing the boundaries of what's possible?
Those are excellent questions, and the truth is we're just scratching the surface of what's possible. But let's delve into some specific areas where this research could have a major impact.
Sounds good to me. Let's start with chip design. How could this newfound understanding of nanoscale heat flow change the way chips are actually put together?
Well, think of it like this. Right now, chip designers are working with like a bit of a blind spot when it comes to heat.
Uh-huh.
They can make educated guesses, but at these tiny scales, heat can behave in like unpredictable ways.
Yeah.
This research gives them a much clearer picture, a more precise set of tools to predict and manage that heat flow.
So they can design chips that are inherently cooler rather than just trying to slap on bigger and better cooling systems after the fact?
Exactly. It's like designing a city with proper ventilation from the start instead of trying to add air conditioning units everywhere once it's already a sweltering heat trap.
Right.
This could lead to like some radical changes in chip architecture, allowing for much denser and more powerful chips without sacrificing performance due to overheating.
That's fascinating. But what about the manufacturing process itself? Could this research impact how chips are actually made?
Absolutely. Right now, manufacturing at the nanoscale is a delicate and complex process. Even tiny imperfections can lead to significant heat problems.
Yeah, I can imagine.
This research could help manufacturers identify and address those imperfections, leading to more reliable and efficient chips.
So we're talking about fewer duds coming off the assembly line, less waste, and ultimately cheaper chips. But that's a win for both consumers and manufacturers.
Precisely. And it doesn't stop there. This research could also have a major impact on fields like artificial intelligence and high-performance computing.
Okay, I'm all ears. How so?
But these fields rely on incredibly powerful chips that generate immense amounts of heat. It's a major bottleneck right now. Imagine training a massive AI model in a fraction of the time, or running simulations that are orders of magnitude more complex, all because you've cracked the code on managing heat at the nanoscale. This is starting to sound like something out of science fiction. It feels like we're on the verge of unlocking a whole new level of computing power. But let's be realistic, this research is still fresh off the press.
Yeah.
How long until we actually see these kinds of advancements in our everyday devices?
It's true that research and development takes time.
Right.
But the good news is this research is already being embraced by industry leaders like Intel.
Right.
Remember, they were involved in the study from the start.
Yeah.
They clearly see the value in this breakthrough and are actively working to integrate it into their manufacturing processes. So maybe not in next year's phone, but definitely in the pipeline for future devices.
Absolutely. And as the technology matures and becomes more cost-effective, we can expect to see it integrated into a wider range of products.
From smartphones and laptops to electric vehicles and even renewable energy systems, I mean, the potential applications are pretty mind-blowing.
It's a ripple effect that starts at the nanoscale and extends outwards to impact our entire technological landscape.
Okay, so we've talked about the potential of this research, but let's not forget that it's just one piece of the puzzle. There are other factors at play here, right?
Of course. The evolution of computer chips is a complex dance between material science, chip design manufacturing processes, and even software development.
So while this research is a major breakthrough, it's not a magic bullet. We still need advancements across all these areas to truly unlock the next generation of computing power.
Exactly. It's a collaborative effort, and this research is a crucial step forward. But what's really exciting is that it's not just about incremental improvements. It's about fundamentally changing the way we think about designing and building technology.
That's a great point.
Yeah.
It's not just about making things a little bit faster or a little bit more efficient. It's about a paradigm shift in how we approach the very building blocks of our digital world.
And that's what makes this research so groundbreaking. It's not just about tweaking a few things here and there. It's about fundamentally changing the way we approach material design at the nanoscale. It's like we've been playing the game on easy mode, and now we've unlocked the expert level.
That's a fantastic analogy. And the implications go far beyond just making our phones a little bit faster. Think about the energy savings we could achieve.
Ooh, yes. That's a huge piece of this puzzle. With energy demand skyrocketing, finding ways to make our technology more sustainable is absolutely crucial.
And that's where this research really shines. By understanding and controlling heat flow at such a fundamental level, we can design devices that use significantly less energy, which is a win for everyone. Less energy consumption means lower costs, reduced carbon emissions, and a healthier planet.
It's a ripple effect that starts at the nanoscale and extends outwards to impact our entire world. Now, I know some listeners might be thinking, okay, cool, but how long until I see this technology in my pocket? What's the timeline for these advancements to actually make it into consumer products?
That's a great question, and one I'm sure many of our listeners are wondering about. What's your take on that?
Well, it's hard to say for sure, when we'll see all these advancements in our hands.
Right. Like we've been discussing, research and development takes time, and the journey from lab to market is rarely like a straight line.
Yeah, but the fact that Intel a major player in the chip industry is so heavily involved is a really promising sign.
Absolutely. Their investment in collaboration suggests that they're serious about translating this research into real-world applications. So while we might not see Mathiessen's rule printed on the side of the next iPhone, it's safe to say that this research is going to have a ripple effect throughout the tech world.
Yeah, and it highlights something really crucial about scientific progress in general.
Right to that.
It's about more than just chasing the next shiny gadget.
Right.
It's about investing in fundamental research, even if the applications aren't immediately obvious.
Because sometimes the most groundbreaking discoveries come from exploring the unknown, just for the sake of understanding how things work.
Exactly. Curiosity-driven research is the engine that drives innovation.
Yeah.
You never know what amazing breakthroughs are waiting to be uncovered when you delve into the fundamental mysteries of the universe.
And this research is a perfect example of that. It started with a deep dive into the behavior of copper at the nanoscale, and look where it's led us.
To a potential revolution in electronics, more efficient devices, longer battery life, a more sustainable future.
And who knows what other seemingly obscure scientific discoveries are out there just waiting to be unearthed and transformed into world-changing technologies.
That's the beauty of science. It's a never-ending journey of exploration and discovery.
And speaking of journeys, this deep dive has been quite a ride.
It has. We've covered a lot of ground, from the intricacies of nanoscale heat flow to the potential impact on everything from smartphones to artificial intelligence.
And through it all, we've seen how a single breakthrough in fundamental research can have far-reaching consequences.
Absolutely. It's a reminder that science is a powerful force for change, and that the future is full of exciting possibilities.
And that's a message I think we can all get behind. So to our listeners out there, keep exploring, keep learning, and keep pushing the boundaries of knowledge.
Because who knows what incredible discoveries you might make and what impact you might have on the world.
On that note, we'd like to thank you for joining us on this deep dive into the fascinating world of nanoscale heat flow and the future of computer chips. We hope you've enjoyed the journey as much as we have.
And we'll see you next time for another deep dive into the world of cutting-edge science and technology.